I think we're live now. Hello, 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 hello. Sorry for the delay, guys. I was basically just kind of sorting out things and we're actually doing a thumbnail for this stream so I get more views, because apparently thumbnails really do help streams. But good evening to everyone, first of all. Let me sort the music out. Let me put the chat here so you guys can see what we're talking, who we're talking to, I guess, right? So let me just sort everything out in the first place. And one of the things I do kind of like hate is just having to set up OBS every time for a stream. Like it's very annoying. But anyway, we'll get there. So we have this here. I already have a message here. Slim, hello. Yo, yo, yo. Make a bash to automate it, joke. Yeah, we could do, guys. We could make a bash script to automate everything. But the only problem is that like every time I open the chat, it's a different link. And it because of that, it's a different like window name. So it'll be difficult to figure out which one is the window for the chat. But yeah. Hello, Peter. Good evening, sir. Good evening. How is it going? Right, so we've got that. Now all we need to do is to actually set up the music. What are you guys feeling like today? I'm going to put something more upbeat because it kind of helps me code a little bit. So I think last time we actually had some DMB, so that's what I'm going to put on today as well. Yeah, I've got this really cool like widget called the Spotify widget for streams, and it seems to work fine so far. Never had any issues with it. But that's what I use for the overlay, if you guys can see that. Hopefully it is working. There you go. Yeah. Now the only thing I have to absolutely do here is get these shit absolutely lined up. Otherwise it's very annoying. No, it's not quite lined up yet. There you go. Better. Better. So now let's get that music and we are ready to go basically. If OBS works, I guess, or Spotify, that is. I'm guessing the volume is still fine. I haven't changed any settings from last time. There you go, Twitch, drum and bass, and let's go. There you go. So we're here and we're ready now. And I've got you guys focused. And yeah, so how's everyone doing today? I hope everyone is having an amazing Friday. Well, it can't be that good, right, if you're on the stream with me. So I guess you guys aren't going out today, but yeah. Hopefully the volume for the music is actually okay. So let's get started. So the plan for today is actually to look at this library or this GUI framework called Slint. I've seen a lot of people talking about it lately, and essentially it's just a like Rust framework. Well, it's all written in Rust actually, but it has bindings for languages like C++. I think it has like Java and Python as well. I was thinking of maybe trying it out today and then seeing if we can get like a simple application running, and how easy it is to actually get like a GUI app up and running on C++ compared to Qt. Because if I'm honest with you guys, Qt is kind of it's difficult. It's very difficult. First of all, you have to build it, which takes about like 10 to 15 minutes depending on your machine. It can take longer if you have a very shit machine. And then you have to obviously read through the entire Qt documentation so you can get something simple out, and if you're feeling fancy you can look into QML and stuff like that. But today we're doing Slint and we're going to compare to that experience to Qt, right? So let's see the demos. Let's see if we can if we can get a C++ demo here. Now question is, have you guys heard of this library? Have you seen it before? Like, it seems like coding Twitter is all about Slint at the moment, but yeah. Right, am I going to get a C++ application? There you go. Okay, so it seems to work on the web as well. Cool. That's really interesting. It just works on the web out of the box. I kind of like that. There's so many different different examples here. So widget gallery. Let's run it on the browser and see what happens. Select style. There's different like looks and feels to it as well. So this is the first time I'm hearing about this lib. Okay. Well, first of all, welcome, Ed. Good to see you on the stream. Yeah, I mean, the first time I heard about it was about a month ago. I think I was watching some guy called the Prime Agent or something like that. I think he mentioned it. And then I watched another guy doing a basic GUI application with Slint with Rust. And that's where I got the inspiration from. And it's been on the back of the list for ages. So here we are on the stream today. But it seems, I mean, in terms of like working on the browser, it seems to be fine. Like I can't really see any issues at the moment. Like it seems very responsive. It feels good. Is there any like more complex? I mean, you can see here some projects on the embedded world as well. So like I guess this is running a GUI on Raspberry Pi Pico, which is a micro. It's a microchip designed by Raspberry Pi. I actually have about 10 of these at home that I've bought and then did like a very simple project and never touched them again. But you know. It seems that it runs on embedded devices as well, which is definitely a good thing. It shows that it's not very bloated, and that is something that I like to see on my libraries. Right, resources. Let's see if we can get the C++, and the website's not very friendly here. Let's get Slint C++ documentation and see if we can get started with it, right? So obviously I've already kind of read through this a little bit for the research today. And Slint kind of has its own markup language for defining the GUI, right? In the same way that Qt has QML, it's kind of the same thing. But the Slint one looks very, very simple, if I'm honest. It looks really, really cool. And you can kind of see an example here. And they talk about the architecture here if you guys are interested. Do check it out. Do check it out because it's worth it. But I'm only interested in knowing how we can get started now, right? Because one of the things I did also look before is the Conan Center, because I was hoping to use Conan to pull Slint into my project. And Slint is unfortunately not available on Conan, right? There is no Conan recipe for Slint. So we're going to have to use whatever they suggest here. So let's set up our environment. So we have to install the binaries from Slint because, as you can probably guess, that markup language has to be compiled into some sort of like binary file, which can then be consumed by the C++ application to show up the GUI. So we're going to have to install the Slint, I guess the compilers. Let's call it compilers for now. They're probably not compilers. But yeah. So let's just download the binary packages, right? So let's look at the releases and download the latest one. Let's do it on my WSL here because I don't want to mess up my Windows system. Okay. And what can we get here? So we've got Slint Viewer for Linux. So from assets, click on the latest release, assets, and then we're going to download the Linux, the Slint CPP, whatever. Wait, what? That one there, right? I guess. Right. So let's just copy this and then kind of put it somewhere in here. Oh. Let's put in the temporary directory that we've got here and let's duplicate that. So what do we have? Slint, let's untar it. So we've got tar xzf Slint. Oh, it doesn't have Slint there. I searched it now. Yeah, it doesn't have Slint, unfortunately, on Conan. I did search it as well, but I was hoping it would be easier than this. But I think it's just simple CMake commands to actually make it available. We can use fetch content, create, and VC package as well. All right, yeah. So it's not available in either Conan or VC package. That's interesting. They definitely need to get on that because quite a lot of people use those two pieces of software for managing their packages in C++, and they're missing out on a big chunk of these C++ users because of that. Yeah, so let's go. So we have Slint directory here, and then we've got the bin. So yeah, we've got that Slint compiler here. Does it run? Yeah, it does. Cool. I mean, this is not what I recommend, but what we can do is we can kind of put this on our path, right? So let's do that. So let's copy this and then just put it on our path. In my case, I'm going to put it on my Z shell RC. There'll be a export path. There you go. I'm gonna put a note to myself to remove it whenever I can. I would 100% forget to do it later on, but path. Ooh. Okay, and then we have to source that again, Z shell C. And now we should have the Slint compiler available to us, right? Great, so it is up and running now. So I guess we have the compiler sorted now, which is one of the first steps. I'm not going to be building it from source. What I do want to know is like, how do they recommend the integration into a CMake project? So yeah, apparently you can compile Slint along your application with CMake. I'm not going to be doing that because we've already got the application. We don't care about the Rust flags. I'm not sure if this is interesting to us. Runtime backend. It's also possible to select any of the compiled in backends and renderers at runtime using, okay, selects the Qt backend. Oh, so it does use Qt. It could use Qt on the backend. That's interesting. Okay, these might be interesting to us later on because we might want to select the Qt one for maximum compatibility here with WSL, but we'll see that. We'll see if we need this. Cross-compiling with not cross-compiling anything. So let's see. Okay, let's see if we can get an example running, right? So do they have examples on their GitHub? Let's take a look. So I know they've got an examples directory here, and you've got a C++ example and a Qt viewer. Let's go for this Qt viewer kind of thing. And they've got CMake lists, which is nice. And let's see what they're doing here. So yeah, for now, let's copy and paste, and then we'll talk for the Qt, because talk through the CMake, right? First of all, let's create a directory for our application. So if you go into development, I have too many different projects now, so I'm probably going to be creating a directory for stream stuff. And then in there we can put in the this lint. Oh, cd Slint. Cool. Now, what we're going to do? So we're going to just open it on code and then start creating the files. So CMake lists.txt is the first one. Great. Let's see if we can also create an executable here. So let's start doing that. So src, and inside the source, we're going to create a new directory called app, right? And inside app, we can have the CMake list as well. CMake list.txt. Okay. I'm going to be adding some executable here. So app, and then this comprises of main.cpp, right? And of course, we're going to have that main.cpp file here. By the way, have you guys got experience with C++? Is it your first time? I know Slim, you've been playing with C++ before, but and Peter, you learn it right at uni. So hopefully, I'm not just chatting shit here, and you guys are actually following through this. Cool. At the very top, at the very end here, I'm going to add this subdirectory, Still carrying on with my C++. Good, good, good. Are you doing CMake as well? Peter, that wasn't very very convincing, dude. You need to get on there. In fact, if you haven't started yet, Peter, I do recommend learning either C or C++ because it does help you out massively with other languages. Like if you understand the basics, of like how memory works, how the language talks to the hardware through like the kernel and syscalls and stuff. And you know, just the very basics of the standard library, like how vectors are kind of implemented, how maps are kind of implemented. You can kind of guess how things are implemented in other languages as well. Like the other day I was doing Golang and I was reading about slices in Golang, which is like the vector type in Golang essentially. But yeah, once you read about it, you figure out straight away like exactly how it's implemented and how it's essentially like a view into a piece of memory and etc. So it's definitely useful. Sure, so talking into account. Yeah. So yeah. TLDR, just keep learning and make sure you get some of the low level stuff as well because it does help you out. That's all I'm saying. So C app. Yeah, let's take a look at the CMake that they've provided to us here. So basically, they're setting the CMake version to 3.21 here as the minimum version. I can actually set mine to 3.27 or 25 actually, because it's a little bit newer. We've got the project name. Let's call it, Slint app or something. We've got languages correctly set to C++. Slim, I'm just falling into the Rust path. I want to go back into C++. Do both. You don't have to stop one to learn the other. Do both at the same time. Because there's no jobs in Rust. Yeah, I'm actually very, very lucky to be working in a company that does Rust. Because quite honestly, dude, if I went to look for a job in Rust now, I probably wouldn't find that many anyway. There's just very, very few. Companies are still a bit skeptical of kind of porting all their systems languages like C, C++, maybe even Java to Rust, just because there aren't many developers out there. And that's the truth. It's hard to find Rust programmers, but it's gaining popularity in the years to come. So hopefully it'll be a better place. But it's worth learning anyway, just in case it takes off. You're one of the first people to kind of know the language, and it's definitely useful having that skill because you can get paid more basically. But yeah, it's not all about the money obviously, but money is good as well. Can't say it's not. Right, so if not target Slint, find package Slint. Okay, so we're just gonna find it straight away. I don't know how find package is going to work in our case because we obviously don't have the package installed anywhere. So again, we have find package qt6 here. Oh, I may, after all, have to use Conan to get Qt in. Can I do it without Qt though? That's my question. So in CPP, right? Platform native. So what is this one? This shows how one can use Slint C++ platform API to integrate into any Windows application. So this uses the Win32 API, which obviously we don't have in Linux. So it might not be the best option for us. This example shows how to use Slint platform API to render a Slint scene in a Qt window. And it's actually using the Qt. Okay, let's do the following. Let's actually create a Conan file or pull it from a different project, one that has Qt in it, and then we can just put it in here, right? It's gonna make life easier for us. So if we copy, let's see which project actually has that. I think Discotech is the one. So that one is a good one for me. So if I go into streams, nope. Why is caps on? CD Slint. Yeah, let's copy the Discotech Conan file into here. Because now we've got a Conan file with Qt in it that should be working, Qt 6.5. And let's install that. Let's do a Conan install to Conan release. Hopefully this should all be built already, so I don't have to actually do a lot of building. Let's see. Because if we do have to build, then it's going to legit be like 15 minutes, unfortunately. But let's hope that it's not the case. So Slim, what are you actually working with now? You said you were a JavaScript developer? Is that... Did I get it right? Or was that someone else? And maybe we can take a look. Yeah, just exploring C++ and Rust. Cool. Yeah, nice. I mean, you're getting some real world experience at work, right? That's always good. But love a Rust. Yeah, I think everyone loves the Rust ecosystem, to be honest. Like, Qt is not supported on GCC. Okay, what can we do now? First of all, do I actually have Conan with Qt in here somewhere? So we have... Please tell me I've got Qt somewhere. There you go, Qt4. Let's see if we can find the version that it's installed. Alright, so this version is 6.5.2. Alright, cool. That's the version I've got installed here. Development streams. Okay, 6.5.2. Which was that one? So why didn't it install Conan? Yeah, I'm not sure. I can't even remember what the error was. Yeah, I mean, Rust ecosystem, definitely better than this now, right? Qt is not supported on GCC 11 and Clang Modern 13 until Conan IO Center is fixed. If your distro is modern enough, set environment variable to... Okay, let's do that. Does that work? Yeah, Cargo would definitely be a lot better than this right now. Like, I always seem to have an issue whenever I'm compiling very large libraries with Conan. Oh, like now, missing pre-built packages. Check the available using. Oh man, this is annoying. This is very annoying indeed. Maybe we move this to Windows then. The thing is, I can definitely fix this if I dig deep. But the problem is, like, it's going to take a lot longer and it's not worth it to do it on the stream. So what we're going to do is we're going to copy things over to Windows, where it definitely will compile, even without Qt, and then we can try things out there, right? I'm not going down the rabbit hole of fixing the Qt Conan recipe again, like I've already done one once before with that audio visualizer thing. And it legit took like 3 days to do it, so I think you need to change your profile. Anton, hello, welcome to the stream. And why is that? Why do you think so? Gee, and yeah, I do agree though. I think I've did my profile a long time ago, so it's probably still a little bit out of date now. So, or did you notice anything wrong? Please do let me know. Alright, so we've got development, streams, Slint. I'm just going to copy this over to C, to Windows. Right, let's open that on Windows then. And let's see whether we can do an installation here. Please just build. Oh, there's something wrong again, just because it shouldn't be building, as I already have. I already have Qt installed, so which version am I pulling? Yes, 6.5.2, so it should be the same one. Yeah, so bear with me guys, this might take a while, but we can just chat in between, right? So this is like just compiling Qt 6.5.2, just so we can use it within Slint, which I didn't know was a dependency, unfortunately. Otherwise, I would have done this before. But yeah, Anton, why do I need to change my profile? I'm still interested. I'm feeling a bit scared now. What did I do? And yeah, let's go back to Slint documentation and take a look at that code, shall we? Oh yeah, really good idea that I had the other day. In your profile, you have a compiler setting. Ah, oh fuck. Dude, like, honestly, you scared the fuck out of me. So you're talking about the Conan profile. And that makes more sense. That makes more sense. I thought you were talking about, like, just my YouTube profile. There was something wrong with my profile. Well, thank you. Probably, yeah. I probably would have to. Although I don't think that's the issue. I think the Conan recipe for Qt is actually just messed up. Yes, I mean the Conan profile. Yeah, sorry about that. So essentially, I've been having issues with the Conan recipe for a while now. I think it needs some more development done to it. But essentially, the message was that it doesn't. That version of Qt is not supported by my compiler, which is version 11 of GCC. And I also have Clang, I think it's 13 or something like that. So that was the error. I mean, I'm not sure if there's much we can do. But my issue with the Conan recipe for Qt is that it's just like generally broken. Like if you look at the pull requests, the issues here, and you search for Qt, you probably see one by me recently anyway. You know, there's a lot of issues with it, especially recently after the change from Conan 1 to Conan 2. Things just broke in general. But yeah, I mean, let's see if I can find my issue here. I can't even remember the issue that I had to fix, which was a while ago. Is even still here. This is not the right Conan. This is not the Conan center. This is not the right recipe. I'm being an idiot. That's the one I meant. Yeah, issues. Click on author. Yeah. Yeah, I was on the wrong recipe. I was on the wrong Git project. That's what I was trying to say. Jesus, the words are just coming out of my mind. Yeah, the issue that I had was something to do with one of the modules not being building properly. And it was closed recently. There you go. I found it. So I raised a PR for this, which was then worked on more by the guy who fixes it, Eric, which does a lot of development for Qt recipes. And that kind of worked, but yeah, I couldn't build Qt statically, and that was the issue. That's not the issue that I've got right now, is it? No. Feature static runtime. There you go. It is still the same issue. That's not kind of fixed, and I can't remember what I did to fix it. In your profile, yes, I'm in Conan profile. Click off. Hello, Matt. Probably CMake fetch content is better at this point. Yeah, B or check otherwise. Take a yes. See you, Slim. Hello, Eduardo. Yeah, fetch content will be fine. I mean, I'm just trying to use the Qt installation that I have already on my machine, basically, and I don't want to have to rebuild it because it will take a long time. And doing that on the stream is not ideal. That's my main issue here. So I'm hitting the same issue that I had before. Feature runtime forcing on breaks its condition, not Qt. Just bear with me for a second while I fix this. There you go, it's the same issue here. Yeah, okay, so let's do that. Can you please retry this option? Yeah, cool. All right, let's try again. Maybe this time it will be a little bit better. And I'm just re-looking at the fix that I suggested in the past for the actual recipe. Yeah, cool. So I need those as well, which I should already have, right? On my CMake lists somewhere on the other project. And I don't want multimedia either. Cool. And it's not being added anyway. That's good. Yeah, cool. I think we should be in a better position now. Let's see if this is going to compile at least. And if it does, we're sorted. If not, I guess we'll try the native API for Slint. So let's just spend like 10 minutes on this. But yeah, going back, I was just talking about some idea that I had in the past. I was thinking of doing like live code reviews on stream. So if anyone's interested in having code reviewed by me, and you don't mind being on stream, of course, I mean, your code being on stream at least, you know, feel free to drop a message and then let me know what project you'd like me to compile, run, and comment on GitHub. And I might do some free code reviews in the future. So just getting the advert out there. In the meantime, let's take a look at what other options we have here. So we have the platform native API, which uses the Win API, and this is obviously something I don't have to compile from source, so it might actually just run. And if we take a look at the CMake lists, what did they do here? So they've got Slint there. Okay, so it just seems that they just link against Slint, right? Which is not bad. Cool. We do, of course, still need to include Slint in our project somehow. So our options are probably just like getting the CMake through fetch content as Eduardo suggested. So we'll try that in a second. I mean, is it building? Yeah, it's building, but it's literally going to take a while. Like, there is 1.4K targets to compile. I'm not enjoying this, so yeah. Let's try running the native API, right? Let's look at the documentation, see how we can include it. We set up the environment, we have, right, built from sources. So include Slint as an external CMake package, built in from sources like a regular CMake project, install it to a prefix. Right, we'll go with this option here, right? So let's do that. We can't find the package yet, so we need to just kind of do this. Get release one. Do I have CMake installed here? CMake language support. enable. Okay, cool. Okay, we've got CMake support now. So what is this doing? This is doing a fetch content declare on the project. It's getting release 1 and it's adding it to api.cpp inside my build directory. That's cool. One thing that I do want as well is I kind of want to come down and copy my CMake presets so we can get this building as soon as possible. This is taking a lot longer to get started than I expected, to be honest. Okay, so we're gonna copy the CMake presets into here, right? So we should have CMake presets. Cool. We've got the presets from a different project I've made before, and this one should have the Windows build settings as well. So essentially, if we reopen this with code, it should detect the CMake presets and ask me which configuration I want to build with, in which case we're going to choose Windows. Right? Some CMake birthdays, okay. I don't know what that means. Let's just click OK. This is taking a lot of CPU power here, I'm not gonna lie. My computer is visibly slow now. Okay. CMake select configure preset, and we've got Visual Studio 2022 release. Let's go for release, right? Or debug actually, which one are we building here? That's a good question. Yeah, we're building release, so let's go for release. Okay, cool. We obviously have an error. We'll look at that in a second. Let's just find the package Slint and see if we can find that. Target. Okay, I don't want to put any of that through. Does it build though? So if we look at VS 2022, I'm not seeing the fetch content working yet. So what's the issue here? Error CMake CSS compiler is not set after enable language. Well, that's interesting. What am I missing here? So project. Okay. Right, the CMake compiler should definitely be working though. What are we doing here? Have we not selected the right one? So we've got Visual Studio release there. There you go. I can see selecting the right toolchain for Windows. Okay, finally found the compiler. There you go. This is nearly done. The Qt build is nearly done, so we may be able to run Qt, the Qt backend in the stream. We'll see. Okay. Yeah, so it's pulling all the Slint stuff now with the fetch content commands, which is definitely a good thing to see. I just gotta wait, I guess. And I want to see if this is going to work. The find package is going to work after we pull everything here. Yeah, I mean, unlike the Ubuntu setup that we had before, we're actually going to build Slint from source on Windows, just because I'm doing everything inside the CMake already anyway. I just want to see which kind of targets it makes available. Choice and use, find Slint in your CMake lists. Okay, so according to the documentation, after this is running, which it doesn't really work, does it? There you go. Slint config is not found. Yeah. Anyway, so we don't need the find package. Sorry, the find package, because we've got fetch content make available here, and it puts everything inside the Slint. I was just being an idiot. So now we can go into my application here. Can we do a target link libraries here? So app public Slint. Is that going to work? Let's take a look. And let's just quickly add a main here, so we can just mimic the compilation at least. Okay, so okay. Now, can we do this? Can we come in here and do an include? What do we have available for us? Slint? Yeah, Slint is available. So we've managed to integrate it with C++. Now, how can I get a hold of the compiler? I don't know. Yeah, I don't know where it built the compiler to, but we'll figure that out. Let's try and do a very simple Slint application using the platform native application here. So we've got the app view CPP. Okay, it may be the case that we have to copy all these things. I'm just having a quick look at what they're doing. Okay, let's kind of copy this file by file. We've got the window adapter here. That would be the interesting stuff, to see how they're adapting this to the Windows API, which shouldn't be that difficult. It doesn't look that difficult anyway. But yeah, let's copy this file by file and try and get something running here. So first thing is we have to copy the Slint file. I believe there is a Slint application or extension for VS Code where you can actually view and edit Slint files. We've installed that. Let's put that inside. Where do we put it inside? Let's put it inside my app for now. So what is it called? Okay, just gonna copy it file by file for now, just try and get it building, and then we edit from there. So you can see VS Code already detects the Slint language, not too bad. Now let's get this app view. Let's create a new folder here for the includes. Oh, that was not what I meant. Okay. What else do we have? I've got the app view.cpp. I guess this is kind of implementing a model view controller kind of thing, right? We'll take a look in a second anyway. Yeah, so CMake, Qt did actually compile, so we'll try the Qt backend in just a second. Well, it might be like a good 20 minutes or so until we get this compiled first, and then we will take a look. So okay, so what are we doing? we forgot a target include directories here. I have no idea why this has been extremely slow. There you go, that's a little bit better. Nope. Oh, okay, yeah, so we're missing app window. That's cool, yeah, it's just a different header. That's cool. Slovensky Nevor, good evening, mate. Hello, mate. It's good to see you on the stream. Welcome, welcome, welcome. We're still getting things up and running, so I know it may be quite boring now, but stick on with us and we'll get something out of today's stream. I promise. What are we missing? We're missing the app window. What? Ah, I see what this is. So app window.h is a header that's going to be generated by Slint, isn't it? And it's going to be generated from this file app window Slint here. So let's see how we can get CMake to kind of automatically compile that for us, right? So, right. Is it going to be here? Compile time, backend selection? No. I just want to see how we can get CMake, or if there's any like command available for us on CMake once we pull this, to get that Slint file and then generate the header for it. So it's a generated file. And one of the things I hate the most working with CMake sometimes is generated files, because they're very fiddly to work with. But yeah. Let's see. I can't really see anything about the compilation of the Slint files, to be honest, on this page. Maybe I'm missing something. There you go, example generated code. So the Slint compiler called by the build system will generate a header file for the root. There you go. That's what I assumed. That's what every generator kind of does, right? Nice to see someone doing C++ streams. Most of the time, I struggle to find a good dev streamer. Mostly just Unity games. Yeah, I've seen a lot of those as well. Like usually C++ streams are like Unity or Unreal, or someone doing something very, very complicated. So like it's hard to follow up. I guess it's the nature of the language, isn't it? Like things in C++ tend to be complicated anyway. But I try to make it simple, and even by trying to make it simple, it's still very, very difficult. So, so right, what can we do here? So this class, okay. So we've got that component. This generates the following header. Yeah, that's cool. But how can I generate that header from it? All right. So this is, I can't believe I'm going to have to use Google for that. So Slint, CMake, generate. Slint comes with a CMake integration that automates the compilation step of the Slint markup file. Okay. No, we recommend using the Ninja generator for CMake for the most efficient build and .slint dependency tracking. Okay, so I worked with C++ back in 2008 and came back to it last year. It became a completely different language. So many, yeah, dude, 2008, that was like before C++ was 11, right? So yeah, it's a very different language now, especially like, even for me, especially with all the like C++ 20 and 23 stuff. It's very difficult to keep track of what you should learn. And unless you're working with it, like it's difficult to know everything from the top of your head, right? It's a massive language. Okay, so CMake prefix installed Slint. CMake prefix path. Wait, what is prefix path again? Does it add the that path to the search paths? I think it does, right? So whenever you do like a find program or something like that, it finds it. There you go. Yeah. So CMake prefix path adds whatever path you specify to the list of paths that you should look for programs, essentially. So, which is good. And then we can do. argument in CMake. CMake list file. In the next section, we will learn how to use the installed library in your application and how to work with .slint. Okay. Right, no. There you go. That's what I was looking for. So now, makes the translation automatic. Okay, so can we do this? What happens if we do this? So there's lint, and then we have, obviously we're going to put it in the other CMake files for the app. Save, why not? So here we have app windows.slint, right? Let's see if this is going to work. This function, I'm hoping that it comes from the Slint CMake, and if not, we'll do something about it. I cannot specify include directories for the target app Windows, which is not built by this project. What? What is Lint anyway? Something like IM GUI. It's yet another GUI library. But it's like a modern Rust library that has C++ bindings, and I thought I would try it with C++ today to see how easy it is to actually integrate it. So far, I'm definitely hitting some walls, but they're not difficult anyway to overcome. It's not the worst yet. But yeah, it's a GUI library. So if you take a look at their website, it's lint.dev, you can see some examples and you can see kind of what it looks like. And in fact, you can like also look at the markup languages. It looks very simple. That's why I wanted to try it, because it looks like much simpler than something like HTML or QML, which is what Qt uses. So what is this? Can we just Google this? Getting started. Okay. So we need an app here. So there you go. Gosh, that makes a lot more sense. I was just missing the documentation. And this seems to be a better example anyway. I don't know how I missed this one. So they've got an executable here. They compile that generated file. And then they do slint on that. Okay. Go to a docs page tutorial. Okay, cool. I will follow your suggestion. So go to docs page and tutorial. Right, where is docs page? Let's take a look. Maybe it's on the main website. And tutorial. Yeah, that makes more sense. Don't know how I missed this. This is actually great. We're going to combine the Slint language for the, okay, the games consist of a grid. Yeah, we can try that. Amazing. Thank you very much. Somehow I was being exceptionally blind and I missed this page entirely. So I've got something very similar to this. Okay, yeah, we can follow this instead of this. So appview.c++. So what else do we have? We've got appview. Where's the generated file getting launched to though? That's the question. So it's not in my build directory. Where is it putting the header file for this one? Are we going to see that? Find Rust, generate that. What if we build it? Does it only work on during build? So you have Oh no, it's actually building the entire thing by itself. This is a Rust build, that's fine. In the meantime, let's read this. Also, it has a line Slint target memory Slint, which is a Slint function used to add the memory Slint files to the target. We must then create in the same directory the memory Slint file. Yeah, let's follow this tutorial. I think this is an easier one, right? So I think we can agree to follow that one. Yeah, my main issue is that like this is not being generated at configure time, which is what I would expect it to happen. So whenever you configure CMake, it will generate memory.h. I have no idea where app_windows.slint or .h is getting added to, or even if it's being generated, because I'm not too sure. Now, one of the things I don't like with Rust applications is that they take a while to compile compared to the C++ ones. But it is what it is, I guess. Okay, let's see if we can get this hello world at least compiled. Oh, I scratched around my back and I hate when that happens. Rust is still compiling. Yeah, we've got this already in our main CMake. All we have to change is kind of like this, right? So let's do that. This is the one. What's this Windows command doing now? That's the interesting. I'm going to change it to app here. App memory.slint. So this is adding a custom command on the target app. So whenever it builds, after it builds, it copies the target DLLs for the app. So it copies all the DLLs from the app's build directory to what? Oh yeah, it copies the runtime DLLs to this directory here, whatever the app is. Okay, yeah, cool. It's just copying the DLLs over. That's fine. For now, let's delete whatever we had here. We don't need them anymore. That was a waste of time, wasn't it? I love when I waste time on stream. Okay. Let's just simply create a memory .slint app and copy this. I missed the T. Cool. Dude, it's still compiling. For God's sake. Surely it's not compiling it again, right? It's not doing the Rust compilation again. That'll be a bummer. I guess we just have to wait. But anyway, let's take a look at this tutorial. So it's just creating a hello world window, which is nice. We need to put this in our main CPP. Feel free to add your favorite IDE for this purpose. Use out of the tree build, okay. Why is it compiling it again? It did it before. Like, I can see it here, right? So it's Slint build. In fact, where is he putting all the Rust builds? That's interesting. Source API, CPP. I would assume it would be here somewhere, right? There you go. Slint compiler is here already. So it's Slint interpreter. It's compiling more stuff. I guess that's the runtime for Slint, isn't it? The interpreter. Yeah, we'll just wait until this is done, I guess. What is the next page out of interest? So what is this doing? Setting the width and height in the background. Memory tile. With the skeleton in place, let's look at the first element of the game, the memory tile. It will be the visual building block that consists of an underlying filled rectangle background. The icon image, later we'll add a covering rectangle that acts as a curtain. Cool. The background rectangle is declared to be 64 logical pixels wide and tall, and it's filled with a soothing tone of blue. Know that the lengths. Okay, so that's just creating like an icon rectangle for it, right? Let's see what it looks like. So you can add an image, apparently. Point to the image, and then the parent width and height. So that just does the entire thing here. Cool. And this is still not, Rust compilation is still not done. That's one of the things I dislike about the the Rust language. Apps and libraries seem to just take forever to build. Thank God it finished, and it gave me an error. App windows. Okay, yeah, that's my bad. That is my bad. I do apologize. So this is obviously wrong right here. Memory.slint is there though. Wow. Okay. It's because it was still compiling from the previous CMake list that we had, which had the app windows. Oh gosh, please tell me it's not going to compile the whole thing again, right? Great, it doesn't. And now things did work. So where did it add the memory header file? That's what I wonder. Because I want to get IntelliSense working. So if I do memory.h. Okay, it is here. Cool. So it does generate it. Oh no. This is Microsoft memory.h. Jesus, it's not what I want. Let's go back. Abort ship. Let's paste that into a main. And this memory file is the wrong one. This is getting the Windows one. It's not the right one. So my question remains: where is the file being generated to? That's what I wonder. Found Rust. And I am indeed compiling that, right? So if I do Slint target sources memory Slint, it goes into my app. Right, I'm a bit confused now because it should be generating a memory.h file and it's not. If anyone knows the answer to this, please let me know because it will help me out quite a lot. Right. can I just kind of run the compiler myself? So let's copy the path to the compiler. Okay, so if I just pass the path, what happens? Okay, so that generates the entire like file. Interesting. So include path for the other Slint files, library. Okay, so we can do something like this, right? We can do memory.slint and output memory.h. So now we have a memory.h. This is probably not how you should be doing this, but yeah, I mean that's the only way to generate this. If I understand well, this function should be generating my memory.h file, right? I'm not sure why it's not doing that. It does say here, and this should look familiar to people. CMake skills, we see that the CMake list references a main.cpp, which we'll add later, and it also has a line slint target sources, which is what I have here, right? Slint target sources, which is a slint function used to add the memory slint file to the target. We must then create in the same directory the memory slint file. Let's just fill it with the hello world stuff. Yeah, maybe I'll get CMake to create this for me. So I can do again, I can probably do a custom command here. And let's look at the documentation for custom command on CMake, because what we're going to do is we're going to run that executable. So for example, we're going to do a find program here, and it's going to be called Slint compiler, right? I think it is. Is that what it is? Yeah, Slint compiler. Slint-compiler. And then we're going to call a program to generate a file. I think this is like it's a very long way to do this, but yeah. What is it? Add custom command. We don't want to do a post build, we want to do a pre-build. So pre-build, this option has unique behavior for the Visual Studio generators when using. Okay, we don't want that. There you go. So this is the kind of example we want, generating a file. Okay. I think this first example should work for us. Let me just make sure here. So it's adding a custom command that outputs table.csv, and this, instead of this, we're going to be running obviously the Slint compiler, and it depends on a file which will be the Slint file, right? So let's kind of do that. Obviously, we want to run the Slint compiler here, right? Somehow. I don't know why I saved it. It's not going to work. Oh, this is going to be called memory.h. So we want to. We can maybe turn this into a CMake function in a bit. Current source directory, and we're going to take in the memory.slint, right? Let's delete this one. and it depends on memory.slint. Add custom target depends on. Okay, so do we then add this target as a dependency though? Generate CSV. I am just reading the documentation here. Just bear with me for a second. Okay, cool. Maybe we'll just do it out with this here. So generate memory page depends on memory.slint. Right, we need to find that Slint compiler. And how do we do that with CMake? We can call the find program function. So we set it to, okay, so find program, this has to go into the Slint compiler. And let's see if it works. Let's first of all see if it works without me having to add the files, the path to Slint compiler as the prefix. Right, so what, yeah, okay, so that did find, did it? I'm not convinced now, you know. So if I do a message as a status, I guess. Yeah, Slint compiler was not found, right? The result will be, wait, if not been found, the result will be var not found options. Okay, so basically we can do an if here to check if it wasn't found. If Slint compiler not found, is it just if or something? Oh, end if? Yeah, it's end if. Yeah, we can do a message which is fatal, I guess. Is it fatal? I can't remember now. Or error? Might be error. Let's say Slint compiler was not found. Compiler. All of this just so we can generate the files with CMake. This has got to be like something that they thought about, right? So I'm just not sure why this function isn't working. That's why I'm doing all of this, because I thought that this function they provide called Slint target sources would actually kind of create that header file, but it doesn't seem so. But yeah, we're doing that. We're automating that with CMake anyways. It's a good practice to do that. CMake error, add a custom rule. What's the issue? Which already has a custom rule, memory h.rule. Oh. I'm not convinced. Is it because of this? Does that work if I remove that? Yeah, so that is adding a custom rule for that memory file. So this must be doing something. This must be doing what we want to do. But he'll be doing it pre-build, right? 100%. Let's look at the CMake. Sorry, the GitHub. Can we search somewhere? So whenever we have that definition function, there you go. So let's look at this one here, Slint macro. Let's see what that function is doing. So it takes each file in the argument and get the file name component. Okay, this is the interesting bit. This is the custom rule. So the output will be in the current binary directory, which is not the source file, so it'll be in the binary directory. .h. And what does it do to the target? That's my question. Set tprop, embedded sources. So target sources for the target, we set, okay, so we just put that in the target. So this is kind of doing what I wanted to do anyway. Yeah, I was just gonna end up writing this by myself, by the way. So this is good that we're looking into this, because it calls the Slint compiler here and then it generates the file. But the interesting bit is that it says it puts it in the current binary directory, right? The current binary directory for me is VS 2022. If we go into source, and then we have the release here. Oh, source app. So this is where I should be putting it. So I'm not too sure why it's not here. Interesting. Maybe if we generate the file, the project. Let's comment this out. Let's reconfigure the cache, right? Yeah, it's still not generating it. So is it only when I build it? It doesn't say it's a pre-build command, right? Depends on that, generating this. Okay, yeah, it generates only when you build it, that's why. Generating memory.h, cool. So now we can see memory.h here. Like, questions were answered, yeah. Questions were answered. Cool. So we have to build it at least once for it to generate the header. Interesting. But anyway, now we should be able to find that, right? There you go. Slint is here. God, that was a rabbit hole, only to find out that it does exactly what we expected it does. So anyway, back to the tutorial. Let's see if we can build it, right? So we build it, and then we didn't completely build. Why? Because Slint properties. What's the issue now? What's the first error that we get? There's a warning here. See declaration of that. See declaration of this. Warning, warning, warning. What's the problem? The following warning is treated as an error. Oh. Okay, for the sake of compiling this, I am going to remove the warnings from my CMake presets. So where's Windows? Adomas, welcome to the stream. Day of Redemption, welcome to the stream, dude. When using Vim, key bindings in VS Code. You should really take advantage of executing motions with numbers. Another powerful Vim. Yeah, I'm aware of that, dude. Don't worry. I like using the mouse sometimes. If you use opening and closing braces, you move the whole paragraph. Yeah, we do, yeah. There's also like end and beginning of words and so on and so forth. So I am looking for my windows. Thanks, I was watching this for quite some time now. It was a bit stressful, this memory stuff. Yeah, I was just very confused as to how it kind of generates the header file, but we got there in the end by finding the source code for it, so I understand it a little bit better now. I'm looking for my VS 2022 release, and I kind of want to remove the warnings, really. So inherits VS 2022. Okay. Hello, QT's better. Good night. Good night, Sop. Welcome to stream, dude. Good to see you again. All right, so let's reconfigure the cache now. It should hopefully work. Yeah, so I'm just removing the warnings from MSVC because there's clearly something in the source code generated by Slint that doesn't compile. So that's unfortunate. This does not compare to Qt, more to Qt. Yeah. To be honest with you guys, it was a bit of a clickbaity title because I knew some of you would join if I put Qt in there, but did it work? Perhaps. But it doesn't compare to Qt. Qt is like actually the rendering engine, right? This is not a rendering engine. It's just an architecture on top of rendering engines like the MSV, so the Win32 native APIs and Qt itself. You can use Qt as a backend, which is what I was hoping that I would get time to do in the stream because I've actually compiled Qt again. So yeah, maybe we'll get to that eventually. So this is like more of a high level framework than Qt is. Should put it that way. Yeah, now it builds fine. So first observation here on this library that I can make is that people are clearly not turning on their compilation flags on Windows at least, right? Especially when the generated code gets done. So that's something they should do. Waiting for Haskell stream, or at least a COBOL stream. COBOL stream, dude. COBOL stream. It might not happen. It's an ancient language. Maybe one day. It's renamed 60 FPS, as I found out. Oh, right. Anyway, so we've got finally, like after literally like an hour and a bit, we finally got an application now, right? So let's take a look at that. So if you go into the terminal, see if it runs at least on Windows, right? That's the problem. Is it gonna run? So build VS 2022 src app. Oh, we've got the app there. So app. Oh no. Wait, what? What's the issue here? So okay, yeah. So CD release. I forget that in Windows that things get put into release or debug. There you go. Yeah, I mean, very small. It says hello world in a very small application here. I'm not sure if you guys can see it. Yeah. There you go. Hello world. So time taken so far, about an hour and 20 minutes. I must say that I did miss parts of the tutorial, which was pointed out by one of you guys. Who was it again that pointed out? Anton pointed it out to me. So I missed out the easy mode tutorial, basically. So maybe if we take away like 20 minutes or so, it takes about an hour if you don't understand any of it, and if you run into issues like I did. Cool. Let's keep going. Let's see if we can learn something about this. And again, this is using the native Windows Win32 backend, not Qt. Yeah, and that's something I'm going to try in just a little bit. Okay, so we've got the bus icon here. We can kind of just copy this and paste it, right? So if we print screen it, I'm going to very lazily save this to somewhere. Pete, high level indeed. Let me keep being attentive then. Adomas, I remember trying out 60 FPS with Rust, but after renaming it, it matured a lot, changed a lot, and it became more attractive. Yeah. So you're saying that this library used to be called 60 FPS. That's interesting. I didn't know about that. I mean, yeah, it seems to have quite a lot of a following now on GitHub at least. So it's interesting. What is this? Okay, this is my downloads apparently. I gotta make sure that I don't share things like this on stream because, you know, in this case, there's nothing really like sensitive here. But like, if there was a picture of I don't know, me or a family member or something like that, you know, it's not something I can share on the stream. But yeah. Anyway, we're safe for now. So let's go into my user profile development here. So where do we? Let's put that into our source app here. Bus. Okay. Now, does it work? Is it just going to pick up the image that's inside the same folder as the memory Slint? Let's hope that it does, right? So I'm pretty sure that we make some changes here. So we'll talk through those changes right about now. So what do we have here? So it seems like we have a component memory tile which inherits from the rectangle. I don't know where the rectangle is. Can we F12 here? No, we can't F12 here. I guess it's like a built-in type, right? And that has a width and height of 64, background of some sort of blue, and the image, let's just put it as, yeah, maybe we create a new folder called icons here and follow the tutorial line by line. icons.buzz.png, right? Yeah. And we've got a memory tile, right? Now if we build this again, it should just be showing it to us, right? So, oh, what did I do? I undid too much there. There you go. What I wanted to do is like build in CMake again. So it should generate the file again, right? Let's see. Yeah, copying the byproducts. That means it's generating and it's building. In the meantime, let's read the comments. I remember trying out FPI. Okay, I read that one. So as a C enjoyer, I simply would say it's useless abstraction layer. It's useless until you spend literally a week trying to show a hello world program instead of an hour. So trust me, I've been there. Was you working with QML in the past? I've actually worked with some QML in the past, yeah. I used to work with Qt back in the day. My first job was writing Qt code, but we didn't write QML at the time. We were using Qt5, I think, and we just didn't adopt it really at the time. So we used to just get the Qt designer out and then design the UIs for it. And then on the back end, we would write all the functionality behind the UI. So QML is kind of a new thing to me as well. I've not got so much experience with it, but I do like it though. It's kind of like what Slint has, right? Anyway, so let's run. Yeah, let's create a run and debug here so we can start running from this. Create a launch JSON, Windows, add configuration. So we have a launch, Windows launch. Where's Windows? Windows launch. GUI App. And we're gonna just put the path to our thing here. So it's build, let me see what it is, build VS 2022 release. And then we have source app release, and then we have app.exe. Current working directory, can be that, I don't care. So if you run it through here, does it work? Yeah, it does. So we have that window with the bus now. Cool. I can see where this tutorial is going. Like they're just going to add like a grid layout kind of thing now with like, I don't know, a 4x4 grid layout, and each cell is going to be one of these things. But yeah, let's follow it and see where it goes, right? So far, so good. We should use ASM everywhere. Yeah, I thoroughly disagree with that, dude. I've never written ASM in my life. I've had to kind of read it before and try to make some sense out of like handwritten assembly. But if you're doing it everywhere, it's wildly inefficient, isn't it? ASM is too high level. Let's do binary. Yeah, I get that you're joking. I just wanted to say that anyway. You think binary is too high level? You should check out the punch cards that they used to do back in the day. I used to work with a person, actually one of the nicest guys I've ever worked with, called Glenn. This was a Jaguar Land Rover back 2 years ago or so, and he told me stories about him writing punch cards programming. So you should check this out. This is like what programming used to be like back in the day. So this is what moved computers, before more modern, I guess, assembly and binary came in. You used to punch cards. This is how you program back in the day. So, but yeah, we're not gonna do any of that today, obviously. Where was I? And we should delete all browsers and directly do API requests from terminal. Yeah, we should delete all the QR readers as well, and then just like decode your QR code in your head as well. There are still some punch cards in my wife's village in Georgia. Interesting time. Yeah, it's very interesting how your programming was back in the day. I wish I had some of that experience just so I can have lived through the entire sort of like transformation. But yeah, man, this is way before my time. Way before my time. I think the word bug comes from actual bugs in the punch cards. Yeah, I've seen that story before as well. I'm not sure if it's true though, but I'd like to think it is. Yeah, I'm not sure if it's true either. Yeah, so okay. Yeah, so let's see where this tutorial is going. But I think we got the basics now, right? So like what is this doing? So polishing the tile. Now let's add curtains like cover that opens up when clicking. We achieve this by declaring a rectangles below the image. So they are drawn afterwards and thus on top of the image. The touch area element declares a transparent rectangular region that allows reacting to a user input such as a mouse click or a tap. We use to forward a callback to the main window when the tile was clicked on. In the main window, we react by flipping a custom open curtain property that in turn uses a property bindings for the animated width and X properties. Let's look at the two states a bit more detail. So, okay, this curtain has two states, open curtain value, left curtain rectangle. Fill the left rectangle half by setting the width to half of the parent's width. And when it's true, width of 0 makes the rectangle invisible. Cool. Does the same for the right one, I guess. I'm not going to read it. What if you pushed the wrong hole? There was no get reset in the past, no, dude. You just have to get a new punch card. It wasn't the end of the world, I think, right? I mean, there was many of them. Well, I guess you could use stickers to fix it, yeah. In order to make a tile extensible, the hard-coded icon names is replaced with an icon property that can be set from the outside when instantiating the element. For example, the final polish, we add a solved property that we use to animate the color to a shade of green when we found the pair. Later, we replace the code inside the memory Slint file with the following. Okay, so let's kind of digest this a little bit, because it's a little bit like it's a big change from the previous one. So I guess callback is like a function definition called click in property open curtain solved icon. So that's what the rectangle is, and we animate. The duration is 800 milliseconds. Image is source icon. Oh yeah, source is the image property here. The width is parent width and parent height. The left curtain is a rectangle with the background of blue again. X is 0, and the X is, if the curtain is open, it would be the width, right? That's where it starts. Yeah, if it's an open curtain, it starts at the end. If it's not an open curtain, it starts on the half. Okay, I'm kind of getting this. I mean, if you guys want, I can do a diagram of this on Excalibur if you want. Slovensky, I hope I'm pronouncing the name correctly, dude. And apologies if I haven't. I also heard from the old folks that they had to wait up to 6 months for their cards to be run on the computer, as our country only had like 2 of them. Very slow debugging, if you ask me. Yeah, that's very debug. It's very costful as well, right? It's costly. If you got it wrong and you didn't realize, then you've got to wait 6 months to find out your program is wrong. It's incredible. I'm curious. Is it hard to stream programming? I mean, do you need to be focused? And us here in the chat, yeah, that's a good question. Amazing question. So it is difficult, like streaming, like live coding. And I am extremely slow when I'm like talking and coding at the same time. For example, like if I'm at work or just coding on my own, I can probably do this entire thing a lot faster, because it's easier for me to like digest the content, read it, and kind of make sense out of the whole thing. But if I'm looking at the chat and talking to you guys, I kind of have to like switch off every now and then. It's not a massive issue. I kind of like it, to be honest. It's better than like coding on my own, to be honest. Like I have something to do, and I don't get bored as easily. But yeah, it's difficult, and that's why perhaps you don't see so many people doing it. Like I know very few successful live coders on YouTube or Twitch. I think most of them prefer to like write a script and do the research before and then publish videos instead, because you know it's very well polished. It ends up being very well polished, and you don't get stuck as much, right? And it looks like you're a genius as well if you do like this entire thing in 2 minutes. Yeah. It looks very good, but you know, do know that when people release videos on YouTube, even me, if you look at my channel, there's a lot of research going on in the background. There's a lot of coding going on in the background, a lot of testing. And if I make it look easy, rest assured that it's, you know, there's a lot of research into it. Your lives in past is 2340. No, I'm in the UK, so it's definitely 1040 for me. In the same time zone, yeah. I'm guessing you guys are what? Germany or Germany time zone, right? Berlin time zone. It's like an hour ahead. Or Spain. Spain is in Adomas. Where are you, dude? Adomas. I can't tell like where that name's from. I'm gonna guess it's something like Greece. Is that correct? Correct me if I'm wrong. Yeah, Germany, Berlin. Cool. Yeah, but are you from Berlin though? Slovensky, you're in the UK. Nice, dude. Yeah, I'm in Manchester, by the way, so probably not far from you. But anyway, yeah. So let's try and run this these new changes here. So he's adding like 2 rectangles for the curtains, and then kind of opening them and closing them depending whether or not a particular boolean solved is set. And there is some sort of like animation going on. I don't entirely know how that works. I think it's probably just a linear animation that goes from like one width to another, but we'll see that working in a bit. And the touch area is what you click on, right? So if click delegates the user's element, root clicked. Okay, let's try and set this up. West London. All right. My name is Lithuanian, but I live in Berlin. Ah, cool. Interesting. Lithuania is like one of those countries where I always seem to find someone from Lithuania, no matter where I am. Like my previous work, that was a Lithuanian guy. I work with someone who's from Lithuania now as well. So it's, you know, you're all very nice as well, by the way. So I'm not saying anything bad. So right. Cool. Yeah, let's move this now to the new setup. Okay, so that should compile, and then the changes we've got. What does this do? Like, is this no coding required so far? Is it all done for the animation? let's build this and see. He became front-end developer. So, I don't know who he's talking about. I'm definitely not a front-end developer, dude. Numerical. I'm only here because you blasphemed by telling Cutie to move aside. It worked. My strategy worked. Yeah, the strategy, I said it before again. It was just to clickbait and see if people would join by shit talking Cutie. Obviously, like I can't compare one to the other because they're not on the same level anyway. But it's good to know that it worked. And welcome to the stream, dude. Good evening. You all got baited, indeed, yeah. All right, so this is my application. If I click on it, it works. So far, there's no coding required. The animations are kind of doing all the work. So let's try and make sense out of this a little bit more here. So as they explained, there's an image that gets rendered first, and that comes from whatever main says here. Okay, so how does it know to get the bus though? I'm interested now. Okay, yes, because it instantiates it at the bottom here. Cool. So create a memory tile with a bus, and then if it's clicked, self-open. Wait, when clicked, it set self-open curtain to no, so it just toggles it. Cool. So let's look at one particular curtain here and see if we can kind of understand it. Well, you got me. Much love from Canada. Thank you, man. It's good to see the Canadians joining on the stream as well. Fuck, what time is it in Canada, dude? Is it not really, really fucking late? Oh, no, it's earlier, isn't it? Yeah, it's the other side of the world. Going left. So you're actually, what is it, like 3 or 4 p.m. or something? 6, cool. So yeah, you have different time zones because Canada is a huge country. I'd love to go to Canada one day. Like, I just never had the opportunity. Yeah, so let's see if we can kind of make sense out of this a little bit on XCaliDraw. So essentially what we have now is like, we've got a square and there is some sort of image in here, right? So can we add an image, or can we just do a free? There you go. There's like a little car. Can I draw a car now though? Oh gosh. This is a little car here that we've got, right? And it's got wheels, of course. It's got some windows. I mean, oh gosh, this looks a little bit phallic. Let's move that away. But this is what we've got, right? And what that is doing, from what I understand here, what this is kind of doing here, so it's adding 2 rectangles as the curtain. So it's adding 1 rectangle here. Let's put it there on top of the image, and another rectangle there as well, right? So right there. And if I understand correctly, this rectangle here is set to the width as the parent width over 2 if it's not solved, right? So if this solved thing here is false, right? Wait, sorry, open curtain. What the fuck is this? No, he became an artist. Thank you. So if the curtain is not open, yeah, the width of the right rectangle is 0, right? So, oh wait, what? Oh no, if it is open, then it's 0. Like this, then the width is 0. If it's not open, the width is the parent width over 2. That makes sense, right? And the same thing for the left one, except for the left one, we're actually changing where the rectangle starts from. So this is the top left here, this is where it starts from. So if it's open, it starts from the end and the width is 0. That's what it's saying, right? I believe. Yeah. Now, if it's not open, it starts on the middle and the width is the parent width over 2, right? My question is like, how is the animation working? Because I'm kind of interested, because like when you click on it, it sets open curtain to true. Is that correct? Where is it? Okay, yeah, there's an animate thing here, so It animates the width with duration of 250 milliseconds, easing in. Okay, kind of similar to CSS then. And this animates both width and this. Okay, yeah, so the left one, like it moves this and moves this at the same time here, over 250 milliseconds, kind of like this, as you can see here. That's cool. That's cool that it has that that functionality, which kind of means, you know, it's not even required for you to write any C++ here to do this kind of application. But yeah, I like it. I like it very much. Now you became front end isn't confusing at all. Yeah, front end is very confusing, I'll tell you that. Like I'm a shit front end developer. Whenever I try to do anything with front end, I just shit my pants basically. I'm a much better just like systems programmer than I am a front end developer. Cool. I mean, we kind of understand the second part, right? So we kind of know how this works. I mean, animation is still a little bit, you know, over my head in this case. Like, what I don't understand is like how when I click on it, it calls root.clicked. So root is here. So like, what is setting the behavior for a click? So like, whenever we click on it, obviously we change the value of open curtain. But where is that happening? That's what I'm not quite getting here. Is it this one? I guess it is, right? So it will be this one. So whenever we click, open curtain is closed. Okay. Yeah, it makes sense now. My bad. So let's go to the new one. And this is, I guess, adding that grid that we said. Yeah, there you go. It's exactly what we said it was going to be, right? So let's see what this is doing. So after modeling a single tile, let's create a grid of them. For the grid to be our game board, we need two features: a data model. This shall be an array where each element describes the tile's structure, such as the URL of the image, whether the image shall be visible, and if this tile has been solved. We modify the model from C++ code. Cool. Well, we're finally getting to write some C++ code to modify this. A way of creating many instances of the tile with the above Slint markup code. Never trust Rust docs. Always trust Rust docs, dude. Like, they're much better than C++ docs. I disagree. In fact, I hate reading C++ documentation. But I love reading Rust documentation because it just seems like there's more explanation and it makes more sense. I mean, obviously it's all due to the programmer writing the library, right? And it just so happens that Rust programmers seem to write better documentations, unfortunately. Yeah. Okay, so yeah, I mean, first we copy the tile data structure definition and paste it inside the memory Slint file. So tile data. Right, what is this changed? So we add in this component memory tile inherits. Okay, so we're adding this shit here. Wait. What are you talking about? What is C++ exactly? What is C++ documentations? The best documentation I came across so far is Golang's. You can write entire servers without barely Googling anything. Yeah, I agree. Golang is really good. I was actually doing some Golang the other day. Is this how you find this channel, by the way? If it is, you know, it goes to show my point here. I mean, yeah, I was writing Golang the other day and then you just F12 into the function definitions and you can see like the entire documentation above the functions. And I absolutely love that. So it makes things very easy to develop. Plus, Golang is actually a very simple language to write as well. It feels like Python, but better, if I'm honest. I love, yeah, Qt's docs are pretty good. I mean, yeah, everything is explained. Well, most things are explained, yeah, but I do like Qt docs. It's one of the few websites where you can actually find like the right information, right, about the library. So we've added that. Now we replace the export comment. Okay, what? This is right. This is a little bit different. So let's see what this is doing. So export component main window inherits window. So where are we on that? Export component main window. So right, we just replaced this with that one. And let's see the differences side by side here. See if we can like compare them. So this one was a very simple instantiation of the memory tile. What are we doing with this now? So we're just composing things, right? Without reading too much, I'm guessing this is going to take a memory tile and create one over and over again over a sort of like grid layout or something like that. Am I right? Let's see. Memory tiles. So we have tile data. What's tile data again? Okay, image, visible, and solved. Okay, so it's like a struct with image, whether it's visible, and whether it's solved. So two booleans and an image. Oh, you can write for loops in this. So for each tile, we create for each tile. Okay, so for each of these memory tiles here, we create a memory tile. Okay, and this is a little bit of maths to basically say this is, you know, to set this the starting, the top left position of each tile, I guess, right? I'm not going to work out the maths, but I'm sure it works, right? So open curtain, tile image visible or tile is solved. Propagate the solved states from the model to the title, to the tile. Okay, yeah, let's go with this and see if we can. Okay, I guess the only thing remaining here is actually to, in C++, we're gonna like, whenever we have a matching image, we're gonna say, you know, this tile has been solved, right? If it's the same name, basically. So if if two images have the same name, you can set them to solved, which means it will turn them to green, which is one of the things I've noticed here that we weren't using before. There's this solved, and if it's solved, it's going to be turned into green. So yeah, let's follow that. I kind of want to do this next step like without actually looking at the tutorial. So maybe we'll try that out, right? But the thing is, I don't know how to, because we need to look at the documentation anyway. So like maybe we'll follow the tutorial. But if we just build it now. I'll tell you what, guys, it's absolutely freezing here in England. It's like nearly 0 degrees, I think, where I live. And I'm right next to the window, which makes it 100 times worse. Cool. So what does it look like now? So I just want to see what it looks like. And we've got this. Okay, cool. Obviously, we don't have the remaining images, so it's just nothing. Let's download them. So, did I forget to download the images? Let's see. Okay, yeah, we do have a... Let's copy that over to our development directory. So we've got a Slint here. Oh, no. We want to put in source, app, and icons. I can extract it to here, please. I've run out of water. My mouth is dry now, unfortunately. Oh, we've got quite a few different things here, actually. Okay. Right, if we build it again, because I'm sure we're going to have to build the files again anyway. Oh, do we get all the images now? We don't. Right, we don't get all the images, and this is one of the things that this could possibly improve. Well, we just added the images to the folder, but the interface file here, I don't know how to call this. The Slint file was compiled before that happened, and there have been no changes on this. However, each of these files did change, so I think it should somehow figure out that the files have changed and we compiled it, but it doesn't do that at the moment. So let's just add a comment here to make sure that we recompile that again. Very easy hack. No, we still don't have them. So what happened? Are they in the right directory? That's the question. Ah, no, they're not in the right directory. They should all be inside icons here. Maybe it did work, we just didn't find out. Let's recompile it again. Slint blog post. The Slint language took some inspiration from Qt's QML. Yeah, there you go. We solved it. Qt, do not move aside. Qt is still better, right? Yay! Now we got it. We got everything here. Cool, cool. Cool, coolio. I actually did some QML. How does it compare? I've not really done much QML, but I mean, this one looks just as simple as QML, to be honest. They're both very similar. I mean, you got to understand that these are like markup languages, right? They're not meant to be difficult. They're meant to be like HTML, like CSS kind of thing. So if it's anything that you know, if you look at it and you read it and you can't understand it, then I would say the language is doing a bad job at being a markup language. So that's all I can say. It's like reading HTML and CSS. I mean, if you don't understand it, you know, you're probably making it too complicated for yourself. So. But yeah, I mean, you know, all of this just creates that very easy GUI application. Like, it's less than 100 lines long, and it's, you know, it's okay so far. Like, it's definitely good. Like, it seems like you can compose a lot of things. Like, we create a structure here for the tile data. Sorry, the image itself, the memory tile, and then we can use instantiation to create it over and over again, which is, you know, something that QML also has, I guess. And then we create a tile data to hold just the data needed to construct each of these in an array here. And then we can also, after that, we can iterate over these like instantiation data here and create each of the memory tiles that we need. So instead of like copying and pasting it over and over again, that's good. I like that. And, you know, the syntax so far is very predictable. Like, it's, you know, for example, if you look at this for loop, it's just a for loop in any modern language nowadays. So I do like it. Cannot complain. Anyway, going back to this, I think this is where we add some C++, right? So if we go back to the tutorial, what do we have? Yeah, so we've got the multiple ones, and now we're going to add some actual C++ here. And let's see how this does it. So we've got a random, yeah, we're going to, I guess, assign them randomly to random places. So what we'll do is take the list of tiles declared in the Slint language, duplicate it, and shuffle it. Yeah, we do so by accessing the memory tiles property through the C++ code. For each top level property, a getter and a setter function is generated. In our case, get memory tiles and set memory tiles, right? So this is saying that whenever we have a property here, memory tiles, this will generate a get memory tiles function and a set memory tiles function. That's what the code generation will do for us. That's cool. Memory tiles. Since memory tiles is an array in the Slint language, it's represented as a shed pointer of a Slint model. We can't modify the model generated by the Slint, but we can extract tiles from it and put it in a Slint vector model, which inherits from model. Vector model allows us to make modifications and use it to replace. Okay, yeah, let's copy and paste it and then run line by line. See what we can find here. So again, this is a little bit more involved now. We need to include random there for the random engine. Now let's kind of try and make some sense out of this. We're getting all the titles here, and that gets us a shared pointer of Slint model, tile data. And then we create a vector of tile data with new tiles, and we reserve twice the memory needed, or twice the space needed as the old tiles there. And then we reserve that, we push them, and then we shuffle the vector. Cool. That makes sense, yeah. And then we put these things into a shared model, right? Oh. Ah, okay, and then we replace the old tiles with the new one. Cool. There's no logic yet to say whether or not you found the same tile twice, right? I guess that's what we're gonna get to in the next tutorial, the next page of the tutorial. There you go. That's cool. So, okay, yeah. You see, whenever you open two of them, if you open the wrong ones, it should close the tiles, right? So that's one of the things I would do myself. Like whenever you open two and they're not the same, you have to close them. If you open two and they are the same, then you have to keep them open and set them to solved, right? That's the logic I'm getting here. Before I even read the next tutorial, I can just we can just kind of tell what's gonna happen. But yeah, we can kind of see what they look like. So yeah, coolio. Yeah, let's get on to the C++ now. See, I want to kind of do the next few parts without the tutorial, but I kind of need the tutorial at the same time to see how we can get the information, such as is this tile open, for example, or can we set a callback from the UI to C++ to say, you've opened a tile somewhere. That is what I wonder. I think that's what we're going to go for, right? And here we go. Game logic will implement the rules of the game in C++ as well. The general philosophy of Slint is that merely the user interface is implemented in the Slint language and the business logic in your favorite programming language. Cool. I'm going to skip this. This is just bloat. So we modify the Slint markup file, there you go, to signal the C++ code when the user clicks on a tile. That's what I was talking about. How do we do this? I think it's a callback, right? So two changes to the main are needed. We need to add a way for the main window to call the C++ code that it should check if a pair of tiles has been solved. And we need to add a property that C++ code can toggle to disable further interaction. Yeah, that makes sense. To keep it open, to prevent the player from opening more tiles than allowed. No cheating allowed. First, we paste the callback and property declarations to main window. So we add these two here. So disable tiles. Wait, main window? Inherits window. Okay, in our property. This is now an in our property as well. What? In our property. Okay, I don't know what in our means, but I guess we'll find out. The last change to the Slint markup is to act when the memory tile signals that it was clicked on. Cool. Before we follow up, I just want to say, if you guys haven't yet, can you please click on the like? It does help me out massively. Turns out that the more likes I get during the stream, the more likely it is that YouTube is going to suggest my videos to other people. So I would appreciate that. if there's still anyone watching, I'm not entirely sure, yeah. So the last change to the Slint markup is to act when the memory tile signals that it was clicked on. We add the following handler to the main window. So for tile in memories. Oh yeah, thank you for the 100s there. I appreciate it. But I mean liking the actual video, going on YouTube and then liking the video, under the video. 9 watching, 9 likes. Smash that like button. Indeed, yeah. Absolutely obliterate that like button. So the last change to the Slint markup is to act when the memory tile signals. Okay. We add the following handler. So this all remains the same. This is what changed. So whenever it's clicked, the tile, if the root is disable tiles, tile image is visible, and root.check if pair solved, right? Let's copy and paste this. I think this is going to boil down to the C++ function, right? This is going to be what we implement on C++, but yes, we're watching. Thank you, thank you. So, right, on the C++ side, we can now add, there you go, the handler to the callback. I don't want to read too much because I kind of want to solve this myself as well, like, but I do want to know how we can set. Okay, let's just kind of look at this. No, yeah, we do need to look at it. It's too much. It's too much for me to figure out everything. So I guess this is what adds the callback on the C++, right? And we're gonna do this after the set memory tiles. Okay, maybe we need to build it again. Even though it's not gonna work, we need to generate the Slint callback. There you go. So that gets created, and it takes in a functor to a callback, which can be a lambda, I guess, right? Which is what we're doing here. What does it take? We have to capture this, apparently. We have to capture this, whatever this is. I don't know why, but we're going to capture that in a lambda. So the main window weak. Oh, it's a weak pointer to the handler of the main window. So it's just an observer pointer. And what do we do? So we lock it. Oh, okay. So we're going to lock that pointer, and then we get the memory tiles, and then we go through all of them, I guess, and then check if they if or not they have open. So first visible index -1, first visible tile. So we've got these two variables that we're going to be going over. Can we rewrite this to be a little bit more friendly? Let's try that. So yeah, as I said, we go through each tile here, and if the tile is not visible and it's not or is solved, we just continue to the next tile. If the first visible index is -1, the first visible index. Okay, so we just keep a pointer, like, okay, right, this is kind of what this code is doing. Let's work it out. So we've got all the tiles here, right? Like we've got like a bunch of tiles, and then we've got like this first tile variable, which points to whatever was the first visible tile, right? Let's say the visible tiles are like a different color, just for the sake of the argument here. So this is just tracking wherever that tile is with this for loop, as far as I can tell. Oh, where is it? And I guess it needs a second one as well. So if the second one, there you go. So it tracks that and then continues to the next tile. If it's not -1, it's pair solved tile equals first visible tile. So if this tile is equals to the first visible tile, right, this is a bit harder. Slint HQ is 40-minute drive from my home, 6 hours to walk. That's good to know, dude. Yeah, Germany actually has quite a few software houses, don't they? Like I remember when I was looking for a C++ job after I quit my previous job, a lot of them were in Germany, and they were taking like remote workers. So in fact, I work for a company now that, you know, half of the company is German, and I do get to go to Germany every now and then. I visit Berlin. I've been to Berlin twice this year, or last year, in fact. We're in 2024 now. So I love Berlin. It's like one of my favorite towns, man. You know, the doner kebabs that you guys have, incredible. You know what I'm talking about, don't you, Adonis? Yeah, so it tracks that first visible index, and then I guess it looks for the second visible tile as well. So there's a variable called isPair solved. So tile equals first visible tile. So if isPair solved, yeah, what is this doing? Oh yeah, so this only looks at tiles that are visible, right? So if it gets to here, we can assume that whatever tile we're on now is visible. So we found the first one in a previous one, and then we found another. I feel like this is way more complicated than it should be. Like, I'm definitely going to rewrite this in a second. Yes, Berlin is full of IT companies. I work in one myself, a software as a service company, but Slint HQ is not in Berlin, it's in Brandenburg, which is outside of Berlin, but I could reach it by public transport. That's cool, that's cool. What is your favorite thing about Berlin? Do you like living in Berlin? Germany also has some insane software engineers. I worked with Volkswagen for 3 years. Their code standards. Yeah, I agree. Yeah, I used to work for. Well, it's an English company, Jaguar Land Rover. We did the cars as well, but we had a lot of work with Bosch, which is, you know, the German software or the German engineering company, and you know the engineers are incredible. In fact, every software engineer. Every German software engineer that I encounter tends to be very good. You guys have a very good education system, I guess, and a very good work-life balance and work. What's the word? You know, you work well. That's what I'm trying to say. You guys work really well. I love living in Berlin. It is very cozy, and I feel like home here very fast. I live here for 5 years now, and I think it's the best city for me. Yeah, if I couldn't live in the UK, I would probably move to Berlin as well. It's a very, very good town, especially for software engineers. So yeah. Just 1 second, I'm replying to a text. Cool. Yeah, I'm definitely going to rewrite this. This is like way more complicated. Why can't we just look at every tile in the first place and then just keep track of the 2 open instead of just one of them and do it in the current? Well, I guess this is more efficient, right? You don't have to keep 2 tiles in memory, which is fine, I guess, whatever. But anyway, so if this tile is the same as the first tile visible, then the pair is solved. We set it to true, and then we set row data first visible index to true, and then this tile is going to be set to true as solved as well, and then tiles model. Okay, cool. Yeah, for software engineers, it's great, but not only that, it has many other advantages like living in a good public transport, good rent prices. Yeah, that's the thing with Berlin compared to the UK. Like the comparable town here would be London, and like you can find a job in London quite easily for software engineers, and they pay really well. Like if you're talking a C++ job, you're 5 years of experience, you're talking at least like 80,000-90,000 a year, I would say. If you go into finance, it's even more. I know people in finance who get paid a lot more than that, but the problem is the rent for a good flat in central London. And if it has like 2 bedrooms, like 1 bedroom for you and your partner, and then another office, shall we say, so you can work from home as well sometimes, that's going to cost you a lot of money. Like, and I mean like 3,000-4,000 pounds at least, which is more than euros as well. So it's very expensive. Also, you don't need to know German to live in Berlin. It's very international. Yeah, that's one of the things I noticed. I love German. I love Berlin in general. So, but anyway, yeah, let's copy and paste this. We kind of understand what this is doing. The only thing I haven't fully got is this bit here, but wait. This has a lambda inside a lambda. Okay, cool. Not a problem. Right, since I've got quite an audience here, who is interested in a free code review for a stream? And if anyone's interested in a free code review for their project, please let me know, and I'm happy to create a video about it. I've been meaning to do something like this for a long time now, so we need to go back to there. What is the issue here though? No matching overload function found. Oh. So I pay €700 a month for 50 square meters. Yeah, that's good. That's really good. 2 rooms in central Berlin location. It's very, yeah, that's really, really good. You see, in London, that would cost, 2 to 3 times what you said there. The landlords here would rent you food, find you for 2K a month. Yeah, that's true. I mean, yeah, Slovinsky, you live there, right? So you know the situation. You know what I'm talking about. So unless it's one of those things. London is good, but unless you're getting paid literally like £200,000 a year, it doesn't really make financial sense for you to move into London unless you're like sharing a flat with other people. Then that's one way to reduce costs. You just rent a room in a flat in a flat share or a house share or something like that. Just it takes time to find a place to live. It's easier to find a job than okay, that's interesting. Yeah, I feel like London isn't too difficult to find a place, but you're just gonna you're gonna have to be willing to pay a lot. That's all. It's not hard to find, but they are expensive. That's how I found it anyway. I mean, right now I live in Manchester, which is the north of the UK, northwest actually, and things here are much cheaper. It's not the cheapest. I mean, it's still, from what I can see, maybe more expensive than Berlin from the looks of it. Like when I was living in a similar flat to you, 50 square meters, 2 bedrooms, I was paying like £750, but that was 3 years ago or something. I'm very lucky as I live with my girlfriend in their parents' second house, so my rent is only dude, you're cheating life, man. You got it easy. That's good though. That means you have to save. You can save a lot of money, right? Working at that job in London. There you go. So that kind of works. It works like we expected it to work, right? Which is cool. Now, rewriting. Let's see if we can do some rewriting. This is basically the game done. I don't assume there's much more to this, right? Yeah, that was it. That was the whole thing. It's a very nice little project for you guys to follow if you want to sort of get into this library. Very easy to understand. I do feel like some of the code could be perhaps a little bit simpler, and that's what we're going to try and do now, but we'll figure it out. When I first came, I paid 600 for a room the size of a public toilet. So that's a London experience for you, dude. But what I do like about London is that there's a lot to do. Like, everyone seems to be in London. You get people from all over the world, like restaurants, food from all over the world, and that's one of the things that I value quite a lot. Especially when I go to London like once every maybe 2 months or so for work, because I work for a London company remotely, so I do have to meet people in there. And I have a good time whenever I'm in London. But does it justify living there, like just to get those experiences? Probably not, unless I'm getting paid a lot more. That's what I can say. Yeah. I'm just kind of figuring out what I can simplify here. See if there's anything we can actually simplify. We could also just leave it as it is. It's not too bad. I mean, I could do something like, use some STD algorithms to transform the tiles into like a tuple of like a tile ID or something like that, tile ID or image name. No, maybe not. So I can just transform the tiles into... I'm trying to think here. Is there an easier way to write this whole thing? I'm not entirely sure how we're just limiting only 2 tiles open at once. That I don't think I understood that yet, to be honest. Where are we saying, you know, if there's 2 tiles open, we don't want to open a new one? Yeah, it's got to be here somewhere, right? So it's got to be like whenever set disable tiles. There you go. So whenever, you know, if this reached, we have 2 tiles. So we disable them. And then we keep them open for a while, right? 1 second it seems. And then we set disable tiles to false as we set the image visible to false on both tiles as well. Cool. I kind of get it. Unugano, hi man, welcome to the stream. Right, how can we rewrite this? I mean, this is very efficient. I'll tell you that. This does the entire thing, the entire game logic in one loop. Now, if you don't care about the efficiency so much, we can bring this into C++ algorithms. So, for example, we can transform the entire tile row, or we can just let me think. We can just kind of we can iterate over all the tiles a few times. The first time we can kind of just filter out the tiles that are open, and if that size is 2, kind of like this, so we can filter with some sort of like ranges or something like that. Filter tiles that are open, and if the size of this filter is 2, we disable the tiles. And also we got to check, I know, if tiles are the same, check solved, right? That's what we kind of did there. If the size of this filter is 1, yeah, if the size is 1, we just kind of do nothing for now, right? I guess. But is this going to be better? Me transforming all of this into a C++ ranges thing going to be better than this implementation? Probably not, to be honest. Yeah, maybe we'll leave it as this. Yeah, no, I'm convinced this is not going to make it more readable. This is as good as it gets. Let's give him some props to this. This is actually this does it very, very efficiently. So like it goes through the entire tiles and applies the game logic all within like one iteration of the loop. I know it takes a little bit longer to understand what this is doing, but it's not bad in the end. Like, this is fine. So refactoring isn't going to help too much, you know. But yeah, what else can we do with this library for now? So let's just check out. If the game is visually a little bare, here are some ideas you can make. The tiles could have rounded corners. Take a look at less sharp border radius property of rectangle. Okay, we can do that. Let's do that. Wait, why can't I find it? Let's see how good it looks. Of the rectangle. Okay. How can I set the border radius of the rectangle? Okay, right, so can we do border radius here? Something like 10 pixels. If we build it again, and if we run it, do they look a little bit rounded now? No, they don't. They do not. Okay, it does look a bit rounded, but only when you open the whole thing. I guess you have to set the border radius to the curtains as well, right? So let's see that. If there is a CSS like thing where you can do like border radius left or something, that would be amazing. Where are we? So can I set the border radius only for like the left and right, like edges, the corners? No, yeah, it seems like it applies to the whole thing anyway, so. I mean, a way of doing that was just to be like starting the windows. Instead of starting it right here, we start it, I guess, like a little bit to the side, but then you might reveal the image anyway. Okay, cool. Let's actually try and solve this though. That's one thing we haven't done yet. Oh, got the wrong one. It's supposed to be this one. We get nothing here after the end, like no fireworks or anything. That would be nice to implement. But the thing is, I'm getting tired, and it is 11:30. So unfortunately, guys, I'm gonna call it a night today. But maybe I'll continue this in the future. I mean, to be honest with you, I did like this library. I wasn't massively like impressed by it. It's nice. It's nice. It has very good animations and whatnot, and you know, once you get it going, it's actually quite easy to develop for it. But it did take me like an hour or so to sort out the problems that we had, and certain documentation on the CMake generator functions weren't quite clear, so we did spend a little bit of time there. But yeah, I mean, thank you all for watching, and what can I say? Thank you for chatting to me. I had a very good time chatting to all of you. I wish you all a good night, and I hope to see you again on the channel at some point. Bye bye. Ciao, ciao, ciao.